discussing organic chemical technology course, and we have discussed module 1, module 2, module 3 and module 4 of this course. Today we will be discussing module 5, and which will comprise sugar and fermentation industry, especially the alcohol which we are getting from the molasses, which we are getting from the sugar plant. So, the coverage as a lecture, that will be introduction of the sugar industry, historical review of the sugar industry, because this is one of the oldest industry, you can say. Then the profile of sugar industry, process steps in the sugar manufacture, byproduct from the sugar plant, alcohol from molasses, different type of alcohol, alcohol from biomass. As you know, the sugar industry is one of the most important agro-based industry in India and has an important impact on the rural economy. India is the first two largest sugar producing country in the world, with sugar production during 2007-8 was 263 lakh tons. There are 624 sugar factories in the country as on 31st 2009. Sector wise breakup is given in other slides, but this is the importance of the sugar. You are saying the different types of sugar that we are making, and there has been a lot of the changes in the quality of the sugar from brown to whitish, means the even from the smaller particle sugar to the cubicle, more larger size of the crystals. So, these are the different type of the sugar that we are making. So, different type of the sugar and alcohol, sugar, good, khad, raw sugar, because this was the khandsari, that was the oldest name that is given, and the initial stages was there in the development of the sugar industry. And raw sugar, refined sugar, soft brown sugar, coffee crystal, granulated sugar, large and smaller size sugar, sugar cubes, different shapes that we are getting, alcohol, alcohol that will be the industrial alcohol, absolute alcohol, anhydrous alcohol that we are making, alcoholic beverage and beers, wines, whiskey, brandy, liquors, different type of the alcoholic beverage, because that from the ancient time we have been using the alcoholic beverage. It is let us discuss about the historical review of the sugar cane and sugar manufacturing in India. It is universally acknowledged that India is the homeland of the sugar cane and sugar. The reference of the sugar cane cultivation, its crushing and preparation of the good in Atharva Veda as well as the Kautilya Arthashastra that has been reported. It is reported as sugar came to India from New Guinea centuries before the Christ. The Indian offering the contain 5 amrits, that is during the any religious function we use the milk, curd, ghee, honey and sugar, which shows the importance of the sugar in our daily life. And sometimes we also compare mithas, that is the sugar, in our daily life. Sugar was made in India during the 4th and 6th century. Crystals prepared from the juice was called sarkara. The word sugar is derived from the sarkara, that the word we are using. Larger lumps was called the khan. It is from India that the art of making sugar is spread to Persia and world over. First sugar plant started at Aska in Odisha in 1824. The first vacuum pan processed sugar was set up at Saran district in Bihar in 1904. By 1931-32, there were 31 sugar mills with total production of 1.5 lakh tons, whereas the consumption was around 12 lakh tons. So, you can imagine the requirement of the sugar that was there. In 1932, India Sugar Industry Protection Act was promulgated, and by 1935, 34-35, 100 alien sugar factories producing 4.6 lakh tons of the sugar came into existence. In 1940-41, there were around 148 sugar factories with production of 11 lakh tons. Growth of the Indian sugar industry, and that was only after the independence. In the organized sector, after industrial policy resolution in 1948 and Industrial Act in 1946, that were there, and the growth of the cooperative sector of the sugar industry. After that, the lot of the development in the sugar production and the sugar mill, setting of the sugar mill came into existence. Later establishment of the National Federation of the Cooperative Sugar Factory was there, and the first cooperative sugar factory was Parwara Cooperative Sugar Factory, which is in Maharashtra, and Maharashtra is also one of the leading sugar producing state in our country. This is the profile of Indian sugar industry and the number of sugar factory, because many of the number that may vary, but this is the figure which I got by 2012. Private sector 245, public sector 62, cooperative 317, and total number of the sugar mill are 624. Capacity is varying very widely. Process technology remaining the same, but a lot of the improvement, technological development that has been done in the sugar plant and the old sugar mill. If you compare the old sugar mill and the new sugar mill, there is a lot of difference in the process technology regarding the refining of the sugar and also the capacity of the plant. In 2010-11, sugar cane was planted in 4.98 million hectares across the country, of which 1 million hectares was in Maharashtra and about 2 million hectares in Uttar Pradesh. Official estimates so. This is the actually you see the Maharashtra and UP and Bihar. These are the some of the major sugar producing states in India. This is the cane production and sugar production figure as on 2010 and 11. The total cane production that was 346 million tons, sugar production 24 to 24.5 million tons. As I told you, the UP and Maharashtra are the two largest sugarcane producing states in the country, accounting for more than 80% of the annual crop production. India is one of the largest producers of the alcohol in the world, and there has been a steady increase in its production over the last 15 years according to the fresh statistic. Actually, you see the molasses to alcohol conversion, now that has become very important in case of, and that will be discussing separately how we are making the molasses and the importance of the alcohol from the molasses in the chemical industry. India is a dominant producer of alcohol in Southeast Asia region with 65% of the total shares and contributes to around 7% of the total alcohol beverage imports into the region. More than 2/3 of the total beverage alcohol consumption with the region is in India according to the figures the newly compiled Alcohol Atlas of India. There has been a steady increase in the production of the alcohol in the country, with the production doubling from 87.2 million liters in 1992-93 to 1654 million liters in 1999-2000, and was expected to travel to 2,300 million liters by 2000. The production, actually the data was not available, so that is more than this what we are having today. Sugar industry is highly seasonal industry. This is one of the problem in case of the sugar industry, with the season lengths of about 6 to 18 weeks for beets and 22, because beet is also one of the source of the sugar, but here we will be discussing mostly about the from the sugar and from the sugar to alcohol, and 20 to 32 weeks for the cane. So, processing in the sugar manufacture, what are the various steps involved in case of the, now let us discuss this manufacture of the sugar. Extraction of this juice This involves washing, shredding and extraction of the juice from sugar cane by milling, and here you find lot of the development that has taken place in milling to increase the extraction of juice from the cane, because the overall economy sugar recovery, that is one of the very important factor in case of the economic, just to have more and more economy. Next step after the extraction of the juice purification. Here also lot of the development, earlier it was the carbonation, now we are also having, we are using the sulfurylation, using this SO2, that is also being used. So the extracted juice is purified using lime and CO2 for removing the non-sugar substances from the juice. Sulfurylation using SO2 is also being used. Then the next step after the juice purification, the concentration of the juice by evaporation. We are having the number of multiple effect evaporator for evaporation of the purified juice, which we are getting, that is around 15%, so that it may be crystallized. So the after the concentration of the juice, that is going to the from the evaporation, it is going to crystallization. Crystallization of the concentrated sugar solution to sugar crystal. Here the crystallization part, that is very important, because the growth of this crystal size, that is very important, which is giving the actually the product, better product quality. Centrifugation, because the separation of the sugar crystal from the molasses or the residue. So centrifugal separation of the crystallized sugar, molasses are left behind after the centrifuging, which is used for the production of the alcohol. So the molasses, which is, that is one of the very important byproduct of the sugar manufacture. Then the further refining of the raw sugar. The raw sugar is dissolved, filtered and crystallized again to get high grade refined sugar. Let us discuss slightly in more detail about the sugar refining part. Sugar refining part, affination, raw sugar mixed with the saturated syrup and then centrifuge. Surface impurities are dissolved and removed. Carbonation using milk of lime and CO2, removal of impurities, color and other impurities which are present in the juice. Sulfylation process, it may be the cold sulfylation or the sulfylation of the after liming. Here in case of the cold sublimation, that is the acid sublimation we call it, because the pH is lower. In the second, when it is along with the lime, it is the alkaline sulfylation that is called. These are the other steps involved in case of the sugar refining, because now you will see in the market a wide variety of the sugar crystals available, larger size, smaller size, more whitish in nature, colorless. Even in color also you will find the different category of the, and so that that also the how the cost of the sugar, that is fixed, that is the purity of the product, color of the product, larger size, lower size, smaller size of the crystal. So for that the further refining, that is very important. So what we are doing, filtration, char filtration, which where we are using the activated carbon for removal of the impurities, and then crystallization. This is the flow diagram of the sugar manufacture, the cane, sugar cane, that is going to the various crusher from where we are getting the juice, and that is going where we are adding the lime, CO2, SO2 and purification that is taking place, and here we are, that is going to separation, removal of the press mud from this, and so after the filtration or through the washer, the cake is separated and the filtrate that is going to the multiple effect evaporator. So, in the multiple evaporator the juice is concentrated and the further refining again it is being done, and then the vacuum pan crystallizer we are using, and the finally in the process we are getting the crystal sugar and the mother liquor for the further evaporation, crystallization, and black liquor, step molasses for the production of the alcohol. So, this is the flow diagram, and the even here also the number of development that has taken place in case of the refining, as I told you. Now, we are also using in addition to activated carbon, ion exchange resin has been also used for the purification of the sugar. What are the major development has taken, because the one of the major problem that has been, as you know, that the recovery of the sugar that is decreasing, especially in the when at the last stage of the sugarcane production, means the during the summer, at the end of the around the March and April, the recovery that goes on. So, what has been done in case of the sugar industry? They have continuously modified development that has taken place to increase the recovery of the sugar. So, for that the new mills they are having the installation of the fibrilizer, which is resulting in the reduced energy in milling and increased extraction of the juice, because that is very important. We cannot afford to lose the juice, because if you are losing the juice it means we are losing the sugar. So, increased number of the rollers, so that the more and more milling and crushing that may be there, and extraction of the juice is more. Reduction in the crushing RPM of the roller, sulfilation process, activated charcoal filtration, and then as I told you the use of the ion exchange resin for the further purification, hydrogen peroxide, sugar remelt ion exchange decolorization process that has been added into some of the sugar mill, where they are extra purified sugar they are making. These are the some of the commonly term used in the sugar industry. That is the first, which I told you, the first step in case of the sugar manufacture, that is the milling. The process of extraction of juice from the sugar cane, breaks unit used to express concentration of the sugar solution. This is the just to measure the concentration of the sugar solution which we are getting. Bagasse, that is left after the extraction of the juice from sugar cane, and this is also one of the very important byproduct of the sugar industry, and normally all the sugar industry they are using bagasse for the power generation in their bagasse based power boiler. But now there is a lot of discussion why not to use this bagasse for other purposes, because you can produce paper from this and let the other fuel be made available to the sugar industry, so that more and more bagasse that we are getting for the making of the paper. Another waste that we are getting from the during the after the clarification of the juice, that is the press mud waste after clarification of the juice that we are getting, that is containing lime. And now they have suggested, because for making some of the biofertilizers, so press mud along with the concentrated waste from the membrane separate process they are mixing there, that is going for the composting. And defecation process used for producing raw sugar. These are the some of the commonly term used. Then the sulfilation, purification using sulfur dioxide, carbonation, that term we are using purification using carbon dioxide, mesquite, the mixture of the sugar crystal and syrup produced by crystallization, molasses, syrup of left after centrifuging and separating sugar crystal. Then the spent wash after separation of the alcohol from the fermenter. Let us come discuss in more detail about the process step. Sugar contains 70%, that is not sugar, sugar cane contains 70% of the water, 14% of the fiber, and 13.3% of the sucrose, about 10 to 15% sucrose, and this is the reason why normally the recovery part which is there, it is around 12 to 13 in most of the mills. So if it is 12 to 13, it is okay. Sometimes it may be, but not more than. And 2.7% impurity. The yield of the sugar depends mostly on the quality of the cane and the efficiency of the extraction of the juice, and that is why I told you the milling process and extraction of the juice and the installation of the vaporizer, that was the reason for going to increase the extraction of the juice. Next step which I told you in this, when I summarized the, that was the in this the abstract which I gave you about the various steps involved, that is the crushing, milling and squeezing of the juice through a series of the pressure mill rolls containing groove walls, weak juice and makeup water is added as extractant before squeezing, just for the to have more and more extraction, that we are increasing, we are using the weak juice there. After crushing and extraction of the juice, bagasse is left as a residue which is about 33% of the total cane crush. Bagasse is used as a fuel for the boilers, and the still whatever the bagasse we are producing, around 10 to 15% of the bagasse is surplus, and that is being used by some of the paper mills, and number of paper mills based on the bagasse has come due to the increase in the production of the sugar cane. Purification of the juice of the removal of the impurities by addition of the calcium phosphate followed by addition of the lime to precipitate the impurities in the form of the colloid, because the purification part also is, that is very important to get the good quality of the sugar crystal. Then the evaporation and crystallization, the clarified juice is concentrated in the multiple effect evaporator to about 40% concentration. The concentrated syrup is again bleached by passing SO2 through it. Concentrated sugar solution is then sent to the vacuum pan where thickened syrup is boiled 3 to 4 times and then sent to the crystallizer where separation of the sugar crystal takes place. Then comes the purification part. We are having the double carbonation using CO2 and double sulfation using SO2. The clarified solution goes to evaporator, and the underflow of the clarified goes to the rotary filter for removal of the impurities as cake, which I told you the rotary filters we are using. The filtrate containing sugar from the rotary filter is recycled. That is the filtrate we are using during the extraction stage. Then it is sent to the high speed basket centrifuge, the concentrated out of the purification for the separation of the sugar crystal. The syrup is concentrated and cooled successively to obtain 1 or 2 crops of the crystal. The final mother liquor called the molasses is sent to the distillery for the production of the alcohol by fermentation process, where a countercurrent flow of water is used to remove the sugar from the beet slices if you are using the beet. These are some of the figures, yield of the various product from the cane crush, bagasse, pressed mud, and again the pressed mud, that will depend upon the type of the purification you are having, whether you are having the double carbonation or the double sulfation, and then the molasses. These are some of the waste product that we are getting from the, this is, we start from the sugar cane tops and the leaves, that is the waste, and that can be used for making the compost, fuel, power generation, animal feed, that is normally it is being used as animal feed, but the dry part that can go, that can be used for gasification also. Then the bagasse which we are getting after the removal of the juice, then that is going to the bagasse fire boiler, bagasse fly ash that can be used for the, and the bottom ash from the boiler that will go to the landfill. And the bagasse which is there, that is having a good amount of the carbon also, so that can be used as adsorbent or for making of the fire brigade. Similarly, the other use of the bagasse, that may be the, as I told you, because now the number of paper mills that has been they are using the bagasse as the raw material, and paper and board, newsprint, also alpha cellulose, building composites along with the bagasse and some of the polymeric compound that you can make the building composites, domestic fuel, furfural from the bagasse that is possible, pottery, litter and the mud, compost wax, animal feed, landfill and the fermentation industry, animal feed. So, this is for the molasses, that is an press mud that can go, because that can be some organic part is there that can be used as a fuel also, and that can be compost also, because I told you now the, because all the solid waste has to be utilized, and so along with the reject from the membrane separation process, we are making the compost also. Now, let us discuss about the ethanol manufacture, because you see the ethanol, that is one of the very important product of the, and many of the sugar mills, they are integrated, they are having the sugar production as well as production of the ethanol. So, that is linked, but many of the mills, they are having the only the sugar making part, and so the molasses which are they are producing, that will be supplied, and this is under control. India is among the two largest sugar producing countries in the world and convert the molasses from sugar plant to alcohol. India is the fourth largest producer of ethanol in the world and second largest in Asia. India produces about 2.75 billion alcohol annual liters, that is alcohol. The demand for potable alcohol has been ever increasing, and the number of the your plants which are making ethanol, they are also making the alcohol, potable grade alcohol, apart from the industrial grade alcohol which we are using. Today 95% of the ethanol is produced by fermentation and only 5% is produced from the petroleum feedstock by ethylene route, because there are number of routes for ethanol is there, but the major production of the ethanol in India and in some other part of the world where the lot of the sugar is produced, like Brazil and the other part of the world where the sugar cane production is more, it is the fermentation of the molasses that we are making the alcohol. Ethanol has become one of the important product as alternative feedstock for large number of the organic chemicals and fuel. That will be discussed in lecture 2 while discussing the ethanol as the biofuel and as the chemical feedstock. Ethanol is an oxygenated fuel that contains 35% of oxygen, which reduces the particulate and the NOx emission from the combustion, and that is the reason why that has been recommended blend of the alcohol along with the gasoline. Now, let us come to the historical review of the alcohol production. So, for the alcohol as a beverage is concerned, that is mentioned in the ancient time back to the Vedic period around 200 BC, drinks som and sura, that was the fermented beverage, and that has been mentioned in our religious books also. Alcohols are also used in the many alcoholic preparation in the traditional Ayurvedic medicine also, because that has been the part of the medicine also, the alcohol. And now you will find the many of the made syrup, cough syrups and all those, they are containing some alcohol also. Fermentation of the fruits to alcohol known to the primitive humans. Usage of the breweries in the ancient time and process of making breweries well established, that the smaller scale operation that was there earlier. Period of the colonial rule saw slow but steady rise in the alcohol production. Development of the fermentation and production of the alcohol from molasses started with the development of the sugar industry. Number of the sugar mills that increased and the production of the molasses was there, and the molasses was made available to the fermentation industry for making the alcohol, that we call it the distillery. This is the various type of the drinks that we are having. So, for the potable grade of the alcohol is concerned, a wide variety of the not only from the molasses root, but other roots are also there, beet, sugar and all those things. They are also from the beet also we are making some of the grape of the fermentation of the some of the fruits also we are doing and making good quality of the things. Foundation of the scientific understanding, that was only after the Lewis and Pasteur who developed the microbiology. Further the development in microbiology and knowledge of the microorganism, because we are using yeast here in the fermentation, and the fermentation technology led to the development of the alcohol industry. Production of the lactic acid, that was in 1884, that is the, so far the fermentation is concerned. The first distillery in India was at the Kanpur in 1805 by Carew and the company, that was in Kanpur. Alcohol is now being used for the potable liquor, as chemical feedstock, as solvent and as oxidant. Various routes for manufacture of the alcohol, because molasses is one route. Molasses from the fermentation of the alcohol from the fermentation of the molasses, alcohol from lignocellulosic biomass, because now a lot of the work is going on. Although this process from the biomass, that was well developed earlier also, but there has been some problem in the pre-treatment of the biomass, and so with the development of the pre-treatment processes and the removal of the lignin, now it is considered as a biomass that can be also a promising source, future source of the alcohol. Alcohol from the starchy feedstock, petrochemical route where we are using the ethylene, and from the ethylene esterification and hydrolysis in various products that you can make. The molasses is the residue left after the extraction of the crystallized sugar and is one of the major byproducts of the sugar industry, and ethyl alcohol is made from the molasses by fermentation process using the yeast in jar. The various steps involved in case of the alcohol production, that is the molasses handling, the molasses you are getting, because in many of the mills they are not having the fermentation plant and the alcohol production is not there. So, that is being supplied to the tanker to the different mills which are having the your fermentation plant. So, the molasses handling, fermentation feeding system, preparation of the yeast inoculum, propagation of the yeast for fermentation, distillation of the dilute alcohol for removal of the impurities, because normally in the fermentation, during the fermentation process we are producing dilute alcohol, and that alcohol that has to be concentrated if you are interested for absolute alcohol. Further removal of water to make the absolute alcohol or even anhydrous alcohol. Now let us discuss the various steps in more detail. The molasses handling involves weighing of the molasses and pumping of the molasses to the molasses tank, from which the major quantity of the molasses is transferred to the fermenter, because that is a continuous process. Preparation of the yeast inoculum, propagation of the yeast. Yeast material is prepared in water cooled yeast vessels by inoculating molasses with the yeast and then transferred to the aerated yeast activation vessel to allow time for yeast cell multiplication, and after that it is being added. Fermentation involves the fermentation of the fermentable sugar by micron and formation of alcohol and other byproducts. Yeast is the commonly used for fermentation of the glucose to ethanol. After the fermentation, alcohol 7 to 8% strength is obtained. As I told you, we are getting the dilute alcohol, and the fermentation is the exothermic process and heat is generated, and so continuous cooling has to be there. During the process also CO2 is removed, and as I told, the removal of the heat is necessary to maintain the temperature in the fermenter. High temperature lowers the alcohol productivity. Nutrients are added to the fermenter intermittently depending upon the requirement, because all the biological process we need the nutrients. Sulfuric acid is added to adjust the pH of the fermenter liquid. Excess foaming in the fermenter is controlled by anti-foam solutions. During the normal operation, treated yeast cells recovered from the fermentation process are washed, recycled from the yeast treatment system to the activation vessel, and after that transferred again to the fermenter. Because when the growth of this yeast that has taken place, then continues the process that is going on. Whatever the yeast that is we are generating during the process, that is again recycled. After the fermentation is complete, the dilute liquor that may be as I told you 7 to 8% or that will vary. 8 to 10% alcohol is preheated and pumped to the beer still, where the alcohol of 95 and where the 50 to 60% and other volatiles like aldehydes are distilled off from the top and sent to the aldehyde column for separation of the aldehyde. This is the impurity that is present in the process and other low volume. The residue from the bottom of the column is known as slopes, and tillages are discharged and treated for recovery of the energy are concentrated and used. This is the reaction that is taking place, and during the process of alcohol manufacturing, lot of the CO2 that is formed, and that CO2, some of the mills they are also marketing the CO2, they are collecting the CO2 and that is being used for the various purposes, because it may be also used for making of some of the useful chemicals. The alcohol drawn from the aldehyde column is sent to the rectifying column, the azeotrope, because here the alcohol and water, that is the famous azeotrope that you are making, is containing alcohol about 95 to 96%, is taken as top side steam from the rectifying column. So the that is the azeotropic mixture is there, and azeotropic distillation is taking place to have the higher concentration. This is the process. You see the molasses is going to fermentation process, it is going to distillery, and then the final products ethanol that you are getting. This is the in detail about the process which I discussed. Molasses, it is going to the diluter where we are adding the sulfuric acid, and after the sulfuric acid it is going to the fermenter. This was I was telling the CO2 that is going to the scrubber, and after that carbon dioxide, this is going outside from the scrubber. The fermenter, after the fermentation we are getting the here the because from the fermenter sludge will be also there, and the your alcohol, dilute alcohol, that is going to the further concentration. The yeast, again as I told you, the yeast which is produced during the process, that is also multiplication, the yeast is there, and so the yeast after distillation again it is going to fermenter. After that, what is going to the analyzer column, where we are further concentrating the alcohol. So spent was is produced. That is spent was, that is a very useful byproduct in case of the alcohol, and this is being used, and this is having very high COD, 1 lakh. So that is the sometime problem also if you are not using the properly this is spent was, and so they are generating the anaerobic treatment of the spent was they are generating, and so this is the what we are doing in case of the sugar industry, where they are having the sugar and alcohol both. So the treatment process, first it is the utilization of the spent was in the anaerobic treatment process to produce the methane gas, which is being used, or the whatever the gases are there, that is being used for the power generation, that is being used in the industry, and then the whatever the spent was after the even anaerobic treatment, that is containing, you can say, around 500 to 10,000 COD, still highly colored material that you are getting after the anaerobic treatment. So, lot of the challenges the distilleries are facing, how to further treat this spent was which we are getting after the anaerobic treatment, because that is highly colored and the COD load is very high. So, some of the place they have because normally in some of the country what they are doing, the treatment of the spent was before going, it is going to anaerobic treatment, they are doing the pre-treatment, and in our country what we are doing, we are using this spent was for the power generation, and then it is going for the further treatment, and finally we are getting the alcohol. You see, the as I told you, this I will be discussing in detail while in the lecture 2, that the what are the different byproduct that you are getting the molasses, and how to utilize the molasses, and they are converting this alcohol, molasses to alcohol and alcohol to ethanol, and that ethanol that is being used for manufacture of large number of the product. This is actually the flow diagram of the various product, that is one of the molasses based chemical plant. This is product profile of the ethanol, that is the fermented was, distillation. So, we are getting the ethanol, spent was, that is going for the biogas generation, which I was telling. After the biogas generation, the whatever the effluent that we are generated, that is going to the further treatment. Now, the Central Pollution Control Board, they are very much concerned about the distillery, because that is one of the highly polluting industry. So, the different type of alcohol which we are getting, that may be industrial alcohol, potable alcohol, and so that may be the extra neutral alcohol, country liquor, all those things, that is the various type of the product that you are getting. Alcohol recovery, that is very important in case of the your alcohol plant, and so this section involves the recovery of the alcohol from the fermentation section to minimize the possible loss of the alcohol along with the generated CO2 and sludge from the fermenter. Another thing that let us discuss, because that was one source, and now the lot of the work that is going on for the production of the alcohol ethanol from the biomass, because the biomass gasification we discussed earlier while discussing the coal and biomass gasification. But another thing that we are interested in utilization of the biomass just for the production of the alcohol. So, technology for producing ethanol from the cellulosic biomass through fermentation and chemical hydrolysis have been developed from lab to commercial scale globally. Even if 10% of the biomass is used for the fuel production, there may be substantial reduction in the alcohol. So, it is being considered the future raw material for the chemical plant as well as a source of the fuel. Ethanol, thus because the gasification route, that is one route, that can be the gasified gas that can be used for the making the that can be synthesis gas, that can be as fuel or making of the various chemicals also. Another route, that is the what we are calling the alcohol from the biomass. So, there may be substantial reduction in the, because that will provide alternative source of the fuel. Ethanol thus produced can be a promising chemical feedstock also. US based Primes Green Energy has developed a high conversion efficiency biomass to gasoline process based on the innovative thermal chemical conversion, and the process can generate 416 liters of the gasoline per ton of the biomass. Lignocellulosic biomass is available abundantly and can be used as the alternative feedstock for bioethanol production. Alcohol from the biomass. What are the process that is involved in case of the when we are using the biomass? Because from you say that during the 30-40 also the lot of the work that was done for the making of the lignin, but the microbiology that was not well developed, the pre-treatment process was not well developed, and so the real actually the work that was started for making of the alcohol from the biomass with the development of the pre-treatment technology and the processes for the removal of the lignin. So, lignin cellulosic biomass includes forest residue such as wood, agriculture residues such as sugar cane bagasse, corn cob, corn stores, wheat and rice straw, industrial residues such as pulp and paper processing waste, lignin from the pulp and paper mills, and municipal solid waste, and energy crops such as the uh, grasses. So, this is the actually the sum of the biomass general term we are using for biomass for this waste material. These have the potential for the use as a feedstock for the production of the fuel and ethanol. The nature and availability of the lignocellulosic feedstock in the different parts of the world depend on the climatic condition and other environmental factors, agricultural practices, technological development. Advantage of the lignocellulosic material: to a larger extent locally, domestically, and provide security for the supply, generate low net greenhouse gas emission, reducing the environmental impacts, particularly the climatic change that we are having because of the deforestation, because of using of the natural resources, also the provide employment in the rural area. This is the cellulosic content of the various raw material, hardwood, softwood, nut shells, corn cobs, grasses, wheat straw, rice straw, cellulose content, hemicellulose. This lignin that is creating problem in utilization of the biomass for the alcohol purpose. Otherwise, so far the biogasification is concerned, no problem. And at the same time, use of the these biomass for the production of the paper, again that will depend upon the cellulosic content of the your biomass. This again some of the agriculture residue that we are getting. Technology, bioethanol from the biomass. What are the technology available? The concentrated acid hydrolysis, dilute acid hydrolysis, enzymatic, because of coming of the enzyme biotechnology, a lot of the improvement in the hydrolysis process that has taken place, biomass gasification and the fermentation. Biomass gasification already we have discussed. This is the fermentation process from where you can get the alcohol. There it will be the biogasification to your synthesis gas to methanol, and that methanol again that can be used for the making of the biofuel. This is the ethanol production per ton of the product, dye product from the various sources: bagasse, rice straw, forest thinnings, hardwood dust, and the mixed paper. This is the cellulose, hemicellulose, and lignin in the biomass, and that is the 40 to 60%, 20 to 40% hemicellulose, and lignin 10 to 25%. Disadvantage of ethanol, because there has been a lot of discussion for ethanol as a biofuel. Again that will be discussed by discussing the importance of the ethanol as a biofuel. But these are the some of the disadvantages which has created problem in utilization of the ethanol as a biofuel. Higher aldehyde emission, corrosiveness, higher latent of vaporization, higher evaporation loss, requiring large fuel tank to lower the calorific value. Below 10% disadvantage are not serious, because normally there is in region Y 5 to 10% blending of the ethanol that has been recommended. The degree of the, when you are going for the bioethanol from the biomass, the degree of complexity and feasibility of the biomass to ethanol depends on the nature of the feedstock. As I told you, the contents of the, because the variation in the composition of the biomass is there. Lignin remains a residual material after the sugar in biomass have been fermented to ethanol, and that lignin, even the separation of the lignin, that is getting problem in case of the utilization of the biomass. Already we have discussed, these are the some of the technology that is available. All the conversion processes in case of the biomass to ethanol that contains the feedstock harvesting, transport and storage, pre-treatment of the lignocellulosic biomass, enzyme hydrolysis of the cellulose in the lignocellulosic material to fermentable reducing sugar, fermentation of the sugar into ethanol, downstream processing of the ethanol. So, these are some of the steps involved in case of the when you are going for manufacture of the ethanol from biomass. So, as I told you, the pre-treatment, that is one of the problem in case of the, but that is the prerequisite. Without that you cannot go for the further other process which is involved in case of ethanol. So, the pre-treatment the biomass is a prerequisite to the biological conversion of the lignocellulosic biomass to ethanol. Pre-treatment is done either physically, chemically or biologically to make the pre-treated biomass more amenable to subsequent cellulose hydrolysis, pre-treatment after the size and structure of the biomass as well as chemical composition, because these are some of the factors that will decide the the pre-treatment impact of the treatment, that will alter the size and the structure of the biomass as well as the chemical composition, because some of the impurity that will be removed during the pre-treatment process. This already I have discussed in this summary. I have summarized the various steps involved in case of the alcohol, that is the cellulosic material which is produced either by acid hydrolysis using sulfuric acid or enzymatic hydrolysis. Both the process that is available, both the dilute and concentrated sulfuric acid are used in the acid hydrolysis. Dilute sulfuric acid involve milder condition than the concentrated sulfuric acid hydrolysis. In acidic hydrolysis, first convert cellulosic material to sugar, followed by conversion of sugar to other chemicals. Enzymatic hydrolysis of the cellulose, another route for alcohol. Enzymatic process requires pre-treatment of cellulose to break the crystalline structure of the lignocellulose and remove the lignin to expose the cellulose and hemicellulose, because this is the reason why the lignin removal, that is very important. Depending on the biomass material, physical or chemical, pre-treatment measure may be used. So, as I told you, the physical treatment method may use high temperature and pressure, milling, radiation, the freezing. The chemical method uses solvent to break apart and dissolve the crystalline structure. This is actually the steps involve biomass. It will go to the hydrolysis, fermented sugar, and then the residue, and then the fermentation process, ethanol, butanol, or the hydrogen, whatever the product that you are. What are the technological barriers? Some of the technology barriers which need to be addressed in the efficient conversion of the biomass to ethanol are the pre-treatment, sacrification of the cellulose and hemicellulose matrix, simultaneous fermentation of the hexose and pentose to sugar. These are some of the technological barriers. All conversion schemes involves following basic step. Already I discussed the feedstock harvesting, pre-treatment, and then finally the hydrolysis. So, this was the how we can alternative source of the ethanol from the biomass is there. In the next lecture, lecture 2, will be discussing about the ethanol in more detail, about how the ethanol that can be used for the production of the various useful chemical, and that is being used in many of the plants. Some are integrated, or in some of the cases they start from the fermentation, and then the ethanol that is being used for the manufacture large number of the chemicals. And one of the because even the starting of the some of the chemical, that was through the ethanol route, not it was the petroleum route, but it was the ethanol route, as some of the example are the Indian glycol, VAM organic, which is now Jubilant Organic, synthetic chemicals Barelli, and some of the other plants, Somaya chemicals. All are there. They are using the alcohol for producing the large number of the chemicals which are now being made from the petrochemical route.